So today we're going to look at building Pong. This is part of Lesson 6, Module 2, Unit 2. After this, you will have to work on the summative project. That should be coming up, so we'll talk a little bit about that after this lesson, but be aware that's coming up next. So, building Pong. We did this in Scratch, so this should be very similar in terms of the game mechanics. You should understand that. But I thought it was interesting to look at the differences between the collisions in Scratch and the collisions in App Inventor and see if we can investigate those and build the same app, only this time it'll live on your phone rather than living on a web browser. So the basic mechanics of the game we shouldn't have to talk about, but essentially we need to code it so the ball moves downward. We need to code it so the ball moves in random directions downward to start the game. The ball has to bounce off the edges and the paddle. The user has to be able to drag the paddle horizontally with their finger. You need to get a point every time the paddle hits the ball. You need to make it be game over when the ball hits the bottom edge. And we need to code in some sound effects for the paddle, the edges, and game over. And the code has to put some code in so the user could check a box to turn the sound off, because that's often a useful feature without having to mute your phone. Sometimes it's useful to be able to turn the sound off a game. So let's dive in and take a look at how to do all those. So first, we got to code the ball so it moves downward. This is the code that we're looking at. Notice we're using the heading. That makes the most amount of sense here. Rather than trying to do some complicated math, especially in those reflections and collisions. Figuring out those collisions with when it hits a paddle or when it hits an edge can be tricky when you're just dealing with the x and y value. When you're dealing with headings, all you're going to do is change the direction it's pointing. So that involves a little bit of math with some angles. Much like how we did with the information in Scratch. We just changed the direction at which the ball was going off in. So we're going to have it start with it sitting in the middle of the screen, canvas width divided by 2. And at the top, that's what the y equals 0. So when it first starts, and we click the start button, that's what it's going to do. It's going to set our headings to 270, which is down. We should know that. Our speed, which is a distance traveled, and our interval to 10. So it's going to travel 5 pixels every 10 milliseconds. So if you want to check what the math on that is, you can see how many pixels it's traveling per second. Step 2, make the ball move in a random direction at the beginning of the game. So we're going to modify this a little bit. So instead of being 270, we want to pick a random number between 225 and 315. That way the ball doesn't just drop straight down. It moves at a slightly different angle when we first start. We don't want to make it go anywhere on the screen. We want to limit that randomness in a range of values that makes sense. So somewhere between 225 and 315 makes sense for this, and we're going to use that random math integer. Now we want to make sure we can get the ball to bounce off the paddle and to bounce off the edge. Well, this one's pretty easy. When it bounces on an edge, all we're going to do is tell it to bounce off the edge. That's it. Handles all the edges. When it collides with the paddle, well, since there's nothing else for it to collide with, we don't need to be specific. If it collides technically with anything on the screen, it's going to take its direction and do 360 minus its current heading. That will effectively reverse its direction. So 360 minus its current heading. You could choose more complicated math. We talked about this before, modifying the collision math. So it mimics more like physics does. But in all honesty, physics typically goes to a stable system. You might even want to modify this. One of the issues with games like this is if you have a consistent prediction in terms of the angle at which it will bounce off, you could end up in a circle and leave the paddle still and never have to touch the game. That's a flaw in a game. A game should not do that. In reality, that happens. It goes to equilibrium. So if you could find that balancing point, you could kind of cheat the game. So game engineers might do something like put in a random value that you add at the end, maybe a random number between 1 and 20, just to tweak the angle a little bit. So that way it's not exactly always the same reflection when it hits, and you don't get caught in that infinite loop. We're going to change this again, go a little bit further, because now we want to make sure the user can drag the panel, but we only want to have them drag it horizontally. So we're going to use the paddle dragged event. So when they drag on the image sprite, which is going to be representing your block, our paddle, it's just a picture, we are going to get the current x value, and we're going to change the y value to nothing. This is the current y value of the sprite, but we're going to get the x value of where our finger is, the current x value. That will have the effect of moving the paddle to the new location that our finger's at. It will have to be a drag, though, so you have to be touching the paddle and then drag. It's not where we touched, it's where we have dragged our finger to. So it won't work unless we're doing a drag. Now we have to modify the score. So every time that ball collides with the paddle, we're not only going to change the heading, but we're also going to have a variable in there called global score. Ignore the line draw through there. I don't know why that's in there. We're going to have a that's going to update the score every time. And we're going to have a method that shows the score. Well, that is done with a label, and we're just updating a label. In this case, we're using a join function to add in the word show with the number. If you wanted to, you could do this with two labels and make it easier. And just have the word show sitting there, or excuse me, not show, have the word score sitting there and not actually have to put the two pieces of text together. What you could do is just have the word score and then have another label that's just going to have the number. We did that before in one of the other games that we did. Game over? Well, this one's a little bit trickier. We have to modify our code that just had the ball bounce off the edge. We're going to modify it to the point that if it hits the edge that equals -1, remember each edge has a numeric value. The bottom edge is -1, the top edge is 1, the left edge is -3, and the right edge is +3. So we want to check using that if-then-else block. Remember, to get an if-then-else block, you have to drag in the if-then block, click on the little blue square there, and then drag the word else into the if-then-else block, and it gives you the block. This is the most silly way of making an if-then-else statement I've ever seen, but that's how they decided to do it. I wish they just had a block in there, but they don't. You have to kind of build it up as you go. So our command will say game over, make the ball disappear by disabling it, if they hit the bottom edge. Otherwise, we're going to just bounce. So we're changing our score so it says game over. If you want to do something more complicated with it, that's fine. If you want to show the score as well, you'd have to join in there and use that join command to add the game over with their final score, so that way they can kind of keep seeing that. Add some sound effects. Again, we're going to just modify the collide with. We're going to set up our sound source. This time we're only using one sound player. And we're going to change the sound in code. Rather than having 3 separate sound players, we're going to have one sound player. And every time we're interested in having a new sound, we're going to set the sound source. In this case, I use a sound called noink. And we're just going to call sound1.play. So that way, every time it bounces off the paddle, say, you know, I'm going to go noink, noink, kind of very gamey-ish. The checkbox. So we're going to create a method instead of just playing the sound. We're going to modify this a little bit better. So we have a method that plays our sound, and we can put in a source. That way, anytime we want to play a sound, this will work. And in here, we have a little if statement that checks to see if that checkbox is checked. If it's checked, then we will actually play the sound. If it's not checked, then nothing's going to happen. We don't need an else in this case. We're not doing anything differently. It's just not going to do anything at all. So there's our little check to get our checkbox so it disables our sound. And that's it. That should be all the pieces. So if we go back to the beginning, these are the steps that you want to follow when you're building this program. Notice we are building it up. There are some things that we're changing as we go through. You want to make sure in code certain pieces work before you go ahead and change them. Some people might say, well, why don't we just build the whole thing all together? Well, because I'm modeling how you design a piece of software. You get some piece of it to work first. And then you say, all right, what do I want to do next? And move forward. And you break it down into steps. This is the brainstorming process. What are the things I need to have happen? And then I'm going to try to make each one of those happen one at a time. The goal is not to make a program work all in one shot, hit run, and watch it run the first time. You don't code like that. You code by getting each step to work one after the other after the other. And then when you're all done, you have a completed program. So I'm going to ask you guys to follow this plan and work on creating Pong. And again, when you're done, you will go into lesson 6, Pong. You will submit it. Here's all of the images that you need. Here's the paddle image. And I think there are some steps with videos. If you want to follow that along, you can do it that way. If you're not sure how to go through this step by step, but it's all right here. Here's some sounds for you. A buzzer, a noink sound, a note, and a ta-da. Feel free to use those sounds when you're adding the sounds. And then you can follow today's notes right here by clicking on notes, and you could just read it rather than scrubbing through the video. That might be a little bit easier. So when you're done, submit the AIA file and the APK file as well. Be sure that you test your program before you do anything else. Okay? And that's it.